Here we're going to look at topic 70, example 2, determine key features of a quadratic function. What are the key features of the quadratic function f of x equals 2 times the quantity x minus 3 squared plus 4? So remember, this is our vertex form, and that's going to become pretty useful to figure out everything that's going on here. So key features, one of the first features, and they're kind of noted down here, we have the vertex axis of symmetry, minimum or maximum, domain, and range. Those are the key features that we are looking for. So the first one we're going to talk about is the vertex. And we already have this graphed here. It'd be pretty easy to figure out the vertex, which is going to be right here. However, what you can find if you don't have the graph, your vertex is your h and your k values. So we have really 3 points here, right? We have a, which is 2. We have this 3 here, and we have this 4. So if we were to write these out, we would say that a is equal to 2, h, right? So if this is, let me move this a little bit. So we have a x minus h squared plus k, and that is our vertex form. So h in this case would be a positive 3. Remember, it's always backwards dealing with h. And then our k value would be 4. So a is 2, h is 3, and k is equal to 4 in this case. Your vertex is hk. So the vertex is going to be 3, 4. And if you pretend that you didn't actually have this graph, then you could figure that out just looking at the vertex form based on hk. If you have the graph, obviously you're just going to figure out where the point is on the graph. All right, so we found the vertex. It's always pretty easy. The axis of symmetry would come next. So the axis of symmetry is any parabola that we're looking at is going to have effectively a right and a left side. And right down the middle of that is an axis of symmetry. All right, and that basically tells us that the left and the right sides are going to be equal to each other. All right, it's symmetrical on the left and the right side. So that axis is where is that vertical line that would go up and down there. So in this case, just make sure I pick the right color. The axis of symmetry is going to be right along here. And what happens is that this is my h value, right? That's where h is equal to 3. So the axis of symmetry is x equals h, which in this case would be x is equal to 3. All right, so you just use whatever the h value is. Let me go back to some highlighting here so we can track this. And the axis of symmetry is just x equals 3. All right, it's that line that goes right down the middle of your graph, or the middle of your parabola, and it should go through your vertex. Your vertex should be on the axis of symmetry. If it's not, you kind of did something wrong. You're just misinterpreting something at some point, or something's mixed up with the graph. Your vertex should always be on your axis of symmetry. Let's just highlight that red, or actually, let's not do that. All right, next we have the minimum or maximum. So what they're talking about in minimum or maximum is that's in relation to the vertex. All right, and they want to know, is the vertex the lowest point on the graph, or is it the highest point on the graph? Well, my vertex, which is right here, is the lowest point on my graph, right? Because the graph is going to keep going up. We'd have some arrows here. This graph will go up forever. So the lowest point, the vertex is the lowest point. So that is going to be a minimum. What helps in terms of that, if you don't have the graph, is just determining whether your graph opens upwards or downwards. So since the a value, that 2 is positive, that tells me the graph is going to open upwards, which means since it's going up, my vertex is a minimum. It's going to be the lowest point. If I had a parabola that was something like this, and it was opening down, then that means this vertex would be the highest point, or that would be a maximum. Okay. So minimum and maximum usually pretty easy to figure out. It's just whether the vertex is the highest or lowest point. Your domain, also pretty easy. In almost all scenarios, it's going to be all real numbers. All right, so there's two ways to write this. We could say all real numbers, and I'll talk about why that is in a second. Or if you wanted to write it in interval notation, you would say negative infinity to positive infinity. The reason for that domain is our x values. All right, and my graph, it's sometimes tough to see, but this graph is going to keep going to the right. So this would keep going right, and this would keep going left. So if my graph just keeps going left and keeps going right, then all my x values are included. The graph is never going to stop moving right. It's going to increase. It looks like it's going up at a much faster rate than it is going left or right, but it is going to keep going right. Very slowly, very gradually, but it is going to go left and right forever. The range, there's a little bit more work involved, but it's not too bad. The range will kind of tie in with the minimum and maximum, and it has a lot to do with your k value. Okay, so k value is kind of, if you think about it, my k value is almost a y value, right? So the range is going to be from the vertex up. So the lowest point of my range, which remember, hopefully you remember, are my y values. The lowest point is 4. So we want to write the 4 as the minimum. It can be equal to 4. So we're going to put a bracket there. And that 4 comes from the k value. My graph continues to go up forever. So there's going to be no real limit to the maximum y value. The graph is just going to keep going up. So this will go up to positive infinity. And we would write that in interval notation. So we'd have 4 infinity as our range. And that's it. Those are your kind of 5 key features: the vertex, the axis symmetry, whether the vertex is a minimum or maximum, and then your domain and your range. So just to kind of review that, your vertex is always hk. So in this case, it would be 3, 4. If you have the graph, it's incredibly easy. If you have just the function, just be careful with the h value. The axis of symmetry is always x equals h. So as long as you got the h value right, you should be good. Remember, the vertex should match up with your axis of symmetry. So this 3 here should be in both of those. The minimum or maximum will be determined whether the vertex is the lowest point or the highest point, and that'll be based on whether your graph opens upwards or downwards. Your domain is almost always real numbers. There's going to be very, very few exceptions, but we're not really going to be dealing with limits here, so you can safely assume that your domain is going to be all real numbers. And then your range will either be a number up to infinity, or, so this is if it opens upwards, or it'll be negative infinity up to that number, and that's if it opens downward, right? Because you'd have a graph that would be here, and you'd have a maximum y value, whatever that happens to be, but the graph would go down forever. So this is a little note for your range. If it opens upwards, whatever that number is, whatever the k value, actually let's take out that number because we would always use k. So we would say k and k. All right, and that's it. Just be careful. No reason to get these wrong as long as you take your time and make sure you're matching up the right numbers and right values in the right places.